Hello viewers, in today's session we are going to discuss an important concept in complex analysis, that is the periodicity of complex exponential function, right? So here we are going to derive the period of complex exponential function. So before deriving the period of exponential function, let us first define the complex exponential function. So here we are going to use this notation, that is capital E of z, where z is some complex number, or we can also use this notation, that is e raised to z, or exponential of z, right? So here these three notations are equivalent, where z is a complex number. So here z can be written as x plus iota y, where I square is equal to -1, and x and y belongs to the set of real numbers, and x is the real part of z, and y is the imaginary part of the complex number z. So now let us write f of z is equal to capital E of z, that is equal to e raised to z, right? So here f of z is a function of z, which is the complex exponential function, right? Okay, so now let us replace this z by x plus iota y. So here we can now write f of z is equal to e raised to x plus iota y. Now we know that the exponential function, it follows the rules of exponents. That is, we can write e raised to x times e raised to iota y, right? Because we know that e raised to z1 times e raised to z2 is equal to e raised to z1 plus z2. So here we have written e raised to x plus iota y as e raised to x times e raised to iota y. Now from Euler's formula, we know that e raised to iota theta is equal to cosine theta plus I times sine theta. So here for theta we have I. So we can now write e raised to x times e raised to iota y. So we can now write here cos y plus I times sine y, right? Okay, so now f of z, which is our complex exponential function, is now given by this expression. Now here we have the cosine function, and here we have the sine function. And from trigonometry, we know that the period of sine function and cosine function is given by 2 pi, right? So the period of cosine function and sine function is 2 pi. So cosine y and sine y remains unchanged when we add 2 and pi to this y, right? So we can now write e raised to x, and here we have cosine y. So cosine y can be written as 2n pi plus y, and here we have I and sine 2n pi plus y, right? And here we have cosine y and sine y, and these two functions remains unchanged when we add 2n pi to y, where n is some positive or negative integer, right? So cosine function and sine function are have the period 2 pi, right? So now again applying the Euler's formula here, we have now for theta 2n pi plus y. So now if we again apply this rule by taking theta is equal to 2n pi plus y, then this expression can now be written as e raised to I theta, where theta is 2n pi plus y. So now we can write e raised to x, and here we have e raised to 2n pi I plus I y, right? So now again applying the laws of exponents here, we have e raised to x times e raised to 2n pi I plus iota y. So we have e raised to x plus 2n pi I plus I y. So now here collecting x and iota y, we have x plus iota y, and then we have 2n pi I. So now replacing x plus iota y by z, we have e raised to z plus 2n pi I. So now our function f of z is given by e raised to z plus 2n pi I. So now we can write it like this: f of z is equal to f of z plus 2n pi I, because here we have f of z is equal to e raised to z, and f of z can now be written as f of z plus 2n pi I, so that here we can see that as if we have replaced this z by z plus 2n pi I. So now this relation is equivalent to f of z is equal to f of z plus t, which is the definition of periodic function, because we know that a function, say f of x, is said to be uh, a periodic function having period t if f of x is given by f of x plus t. So if f of x is equal to f of x plus t, where t is the least quantity such that f of x is equal to f of x plus t, then t is known as the period of f of x. And here we have now this relation, that is f of z is equal to f of z plus 2n pi I, that is f of z is equal to f of z plus t, where t is now 2n pi I, right? And if we take n is equal to 1, then the period t is given by 2 pi I, right? So the period of the complex exponential function, that is e raised to z, where z is some complex number, the period is given by 2 pi I. So here we conclude that the period of complex exponential function is also a complex number, because 2 pi iota is a complex number. So the period of complex exponential function is a complex number that is given by t is equal to 2 pi I. So now we can write this relation as f of z is equal to e raised to z plus 2 pi I, that is equal to f of z plus 2 pi I.